Welcome back to the Network Engineer Diaries. I'm Jimmy Shaka. Today we are going to talk about virtual local area networks, VLANs, what they are, what they do, how to configure virtual local area networks on switches, and later on in this section we're going to talk about how to route traffic between different VLANs using a router, or using a layer 3 switch. There are three things to consider when designing your local area network. The first thing is scalability, how scalable your network is, performance, and security. When designing your network, the typical topology usually consists of 3 layers. You have your access layer, distribution layer, and core layer. The network topology usually consists of 3 layers. We have the access layer, the distribution layer, and the core layer. This is an example of a campus network design. As you can see, we have the 3 layers labeled. The first layer, you have the access layer. The access layer provides connectivity for your computers and host devices, whatever they might be, to the switches in Layer 1 access layer. Desktops usually have one network interface card, but other end host devices like servers usually have dual network interface cards to be able to connect to a pair of redundant switches. At the access layer, that's where client access security measures are enabled. The access layer uplinks to the distribution layer switches. The switches in layer 1 in the access layer uplink to the distribution layer switches. The distribution layer switches are going to act as the aggregation point with the access layer, and they provide that scalability that we talked about earlier. Distribution layer switches, they're going to be deployed in redundant pairs usually, with downstream access to layer switches, to access layer switches connected to both. As you can see, every one of these switches in the access layer every one of them is connected to both switches in distribution layer. As you can see here on this diagram, that is to provide the redundancy just in case one switch in the distribution layer goes down, the other one can still provide connectivity to the access layer switch. Typically, you're never going to have an end host device connected to a distribution layer. The distribution layer switches at this level, at the distribution layer level, that's where you're going to have the software policy such as quality of service enabled. Going up one more layer, we have the core layer. The distribution layer switches uplink to the core layer switches. Traffic between different parts of the campus is going to travel through the core layer, typically speaking, and the core layer is going to be designed for speed and resiliency. So we are going to avoid configuring any software policy at the core layer. Like we said in the previous layer, the distribution layer, core layer as well, you have to provide the redundant pair switches over there as well, and that is for just in case if one switch goes down, the other one can still serve the distribution layer downstream and then to the routers upstream. Those are the 3 layers that you're typically going to encounter when designing your network. A quick overview. Routers operate in layer 3 of the OSI model. Routers don't forward broadcast traffic by default. Security and performance is achieved at layer 3 by splitting networks into smaller separate domains. Hosts in different subnets send their traffic through a router. That means if the engineering department computer, let's say it is set up in a separate subnet and it wants to communicate with the sales computer that is set up in another subnet, a router typically is going to be needed here to be able to send that traffic from between the 2 computers. Network security policies can usually be configured at layer 3. On the other hand, the switches operate in layer 3 of the OSI model. They forward broadcast traffic by default, and this bypasses routers and firewalls security policy at layer 3. And obviously, this is going to raise performance and security concerns. Now, what do we do? Because the switches are going to broadcast the traffic everywhere, and that is a performance and security concern. That's why we have VLANs. VLANs, this stands for Virtual Local Area network. The VLANs, they segment the local area network into separate broadcast domains at the layer 2 on the switch. Every subnet gets its own virtual local area network. Typically, there's a one-on-one relationship. That's where virtual local area network come in, VLANs. The VLANs, they're going to segment your local area network into separate broadcast domains at layer 2. And every subnet will get its own virtual local area network. Typically speaking, there's a one-on-one, one-to-one relationship, meaning subnet X will get VLAN and then subnet Y will get its own VLAN. That's typically speaking. With VLANs, broadcast traffic is never flooded everywhere on all the network. It's only limited within that VLAN to all the end hosts and devices set up in that VLAN. All these above discussed points are going to increase the security and performance in your local area network, because the broadcast traffic will no longer be sent to all devices, but it's going to be limited to only within the virtual local area network. And if two end hosts want to communicate and they are set up in different VLANs, VLAN X, say, and VLAN Y, a router or a layer 3 switch is going to be used to route that traffic between VLANs. When we are configuring VLANs on the switch, we have access ports. Access ports are configured on the interface where the end host is plugged in. One VLAN is configured on an access port. Switch, like we said, the switch will forward the traffic within the same VLAN, and the traffic between different VLANs is going to require a router or a layer 3 switch like we discussed earlier. Now, if a switch is communicating or sending traffic to an end host, that's where we use the access port. Now, what happens when a switch wants to communicate with another switch? Like, let's say traffic goes from one host through switch 1, and then switch 1 sends that same traffic to switch 2 before it arrives to the other end host, let's say computer PC 5 in a different office. That's what we're going to have with the Dot1Q Trunk. Trunks are used to carry traffic for multiple VLANs, for one switch to another switch. Trunks are configured on links that are between two switches. The inter-switch link ISL, which is now obsolete, it was a proprietary trunking protocol by Cisco. How does Dot1Q Trunk work? The switch that's forwarding the VLAN traffic is going to tag the Dot1Q header with the correct VLAN, and the receiving switch on the other side will only forward the traffic out ports that are in that specific VLAN. The switch removes the Dot1Q header from the Ethernet frame when it forwards it to the end host, and the end hosts are not VLAN aware, typically speaking. Now, what happens when you have a very big campus? Obviously, you're not going to be able to configure on every single switch. That's where the VTP comes in. Virtual Local Area Network Trunking Protocol, VTP. It allows you to set up a switch as a server and have that one switch feed its VLANs across the network to all switches that are set up as clients. So the server switch will typically should be able to edit, add, delete VLANs. A server switch synchronized with other server switch with higher revision number. A switch that's set up as transparent switch, this switch will not be able to participate in the VTP domain. However, it's going to receive the VLAN information and pass it on to the next switch. However, the transparent switch can add, edit, and delete its own VLANs within its VLAN database. Client switch, on the other hand, they can only receive VLANs from the server switch. The client switch cannot edit, add, or delete VLANs of the other switches. VTP is useful for large campus networks. It saves us time from having to set up VLANs on every switch manually. If you had hundreds and hundreds of switches, let's say within a campus network, obviously you're not going to set up VLANs on every one of them individually, because that would take you a very long time. VTP is going to be used for this. You're going to set up one switch as a server or multiple switches as servers, and then the rest as clients, and then the server are going to feed their VLANs, the VLANs that you set up on the server switch, to the client switches automatically. Let's see this in the lab. We're going to use Packet Tracer. As you can see here, we have two offices here, Office 1 and Office 2. Office 1 has these 4 PCs, 3 engineering PCs, 1, 2, and 3, and 1 sales PC. On the other side, we have Office 2, which has 5 PCs, 3 sales PCs, 1, 2, 3, and 2 engineering PCs, engineering PC 4, engineering PC 5. And in the middle, we have a layer 3 switch that's connecting the two offices. And right above it, we have a router. Let's see how to configure this in the Packet Tracer.